Hello out there, welcome to this tutorial on geometry of a straight line. This is part 6 of this tutorial. If you are joining us now, check the description section of this video on our YouTube channel to get the link to other videos on geometry of a straight line. In this video, we'll be looking at problem involving triangle. So we have our problem. The coordinates of the vertices of triangle ABC are A 5, 5, B -6, 2, and C -2, -4. A. Show that the triangle is isosceles. B. Calculate the area of the triangle. In our solution, we first sketch the triangle A, B, and C. The sketch must not be on a Cartesian plane. This is just to guide us in our solution to the problem. In order to show that the triangle is isosceles, starting from A, we need to find the length of the sides of the triangle. So we start with line AB, and you remember the formula for calculating the distance between 2 points or length of a line given the end points. So we then go for point A and B, and we name the points x1, y1, and point B to be x2, y2. So substituting into this formula, we have square root of x2 is -6 minus x1, that's -5 all squared, then plus y2 is 2 minus 5 all squared. So simplifying this, we are going to have square root of -6 minus 5 gives -11. Squaring -11 gives 121. 2 minus 5 gives -3. -3 squared gives 9. So we have a square root of 21 plus 9, which gives square root of 130 units. That is for the side AB. Then we go for AC. In the same way, we still maintain the point A to be x1, y1, and point C now will be x2, y2. So substituting into the formula, this is square root of x2, which is -2, minus x1, which is -5 all squared, then plus y2 is -4, then minus 5 all squared. -2 minus -5 gives -7. Squaring it will give us 49. Then plus -4 minus -5 gives -9. Squaring it will give us 81. 49 plus 81 gives square root of 130 units. And the last one is BC. So we cannot just conclude like this. We need the third side. So here our B is going to be x1, y1, and then C will still be taken as x2, y2. So substituting into our formula, we have square root of, that's -2 minus -6 will give us +6 all squared, then plus y2, which is -4 minus 2 all squared. -2 plus 6 gives 4. So square 4 will give us 16. -4 minus 2 gives -6. Squaring it will give us 36. That's giving us plus 36. And we have it as square root of 52. 52 is 4 times 13. And the 4 is a perfect square. We can have the simplified form of root 52 to be 2 root 13 units. So we've gotten the three sides of the triangle, and we discover that AB is equal to AC. So we then conclude the triangle is isosceles. And that's all for the solution of A. We then go to B. So for B, we are to calculate the area of the triangle. Let us calculate the midpoint of BC, we'll then be able to get a height. So let's see the midpoint of BC, midpoint of BC. So we see, remember, it is going to be sum of the x coordinates divided by 2 and the y coordinates divided by 2 to give us the point. Name the points B and C to be x1, y1, x2, y2. As A will be -6 plus -2 divided by 2. This is -8 divided by 2. -8 divided by 2 gives -4. That is x coordinate. Then for the y coordinate, we have 2 plus -4 divided by 2. This is giving us -2 divided by 2, and that gives -1. So that the midpoint is -4, -1. We can then draw the perpendicular height. We call it h. From here now, we can now find h using distance between 2 points, so that we now have it as square root of -4 minus 5 all squared, then plus -1 minus 5 all squared. This is giving us 81 plus 36. -9 squared is 81, -6 squared is 36. This is giving us square root of 117. In a simplified form also, we have it as 3 root 13 units, because 117 is divisible by 9. So that is that. We've gotten our height, and area of a triangle is half times base. Our base is 2 root 13 multiplied by the height, which is multiplied by 3 root 13. These two, we cancel these two, we'll be left with root 13 times 3 root 13, and that will give us a 39 square units. And that is representing the area of the triangle ABC, which represents the solution of problem B. And this is the end of this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Also remember to check the description section of this video on our YouTube channel to get the link to other parts of videos on geometry of a straight line. Until we come your way again, goodbye.